I think that rubbish is absolutely fascinating. So I'm going to talk about, I sort of ramble around rubbish and recycling. And I'll answer a few questions. I'll ask an awful lot more questions. And so, I mean, it's a very difficult field, I think. There are very few good answers here. And there are a lot of quite vexed questions. So there's a sort of ramble round the territory. So we're going to look at rubbish in general and think about, you know, what recycling is and whether or not we might do it, and think about some of the considerations for how you evaluate whether you should do it or not. And I'll use a range of examples from different materials. So in some areas, we do quite a lot of the, you know, the proper recycling. In others, it's much more this sort of wild diagram up there, which maybe there's some stuff going around in the middle, but there's stuff flying out in all directions, and that's much more real life. So I'm going to start off with a few definitions. So recycling is, of course, not a new concept, but that word was used in the oil industry to talk about you know, getting oil, retaining oil in the loop. But then it got sort of institutionalized. And so the collection of valuable post-consumer goods, that was called recycling, but not until about the 1960s. And of course, now it's very much in our vocabulary. But I still think that, you know, the word recycling, most people think of as just reusing material. And they often use the word in a way that I don't think is quite correct. And so I'll be a bit nerdy about some of the definitions that I give. But basically, the idea of reusing stuff has been around since we've had stuff. I'm going to talk a bit about the waste hierarchy, which I think is a really useful concept. And I'll keep on coming back to that in the concept, in the context of recycling. So, waste. Documented waste, so waste management. So Knossos, landfill sites are documented, we know about those from 3000 BC. A bronze scrap, which of course was always reused, but here was a sort of institutionalized version of that. Municipal landfill sites are not new. They had to be at least a mile beyond the city gates. Paper recycling in Japan. Rakers in in London. Of course, big cities present particular problems because people can't dispose of their own rubbish in a way that's acceptable to other people, and so you do have to have some sort of organized collections. And then in the 18th century in London, we got dustmen. I don't think we call them dustmen anymore, but that's quite recent. So dustmen. And they would collect stuff together, and anything that was valuable would be sold on. And then we had fibre, which was collected and making shoddy. And then the rag and bone men, which for people of the great age of people like me and John, remember from the streets. But I think they've gone away completely now. They're now men in white vans, I think, who perform some of the same operations and not necessarily asking before they take either. Now, Cambridge was really rather forward-looking with Cheddar's Lane. So this was a pumping station which was powered by burning rubbish in the destructor, the waste destructor with that chimney. Second World War, so anything of value was retained, and so there were organized salvage collections to gather that up. But then at the end of the war, people with a great sense of relief started conspicuous consumption, and that is the beginning of our problems that we have now that we're tackling. And so landfill became the cheapest option, and we're running out of landfill sites now, or have run out of them in some parts, and so that is driving the sort of reversing of the trend, really, that we're starting to some of us try to regard rubbish as being a useful commodity and thinking carefully about how we dispose of it. In places in the world where landfill sites are still commonly available and there's less pressure on space, then people are less aware. And so in the United States, where they seem to have an awful lot more space around, their recycling rates tend to be very, very much lower than in the populated Northern Europe. Then we started to get legislation in place, so EU directives and waste strategies, which were designed to try to tackle the situation. So, what do we have now? So this chart here shows us what we used to put in our bins and what we put in our bins more or less now. So it used to be mainly dust. And this is, municipal collections rather than from the countryside. And so this was things that people couldn't dispose of in their backyard. So the dust bit from the dustmen has pretty much gone away. And you can see plastics coming in since beginning in the 1960s, but then forming quite a big fraction now. And the kitchen and organic waste increasing. So we're throwing away a lot more food than we used to. And the miscellaneous is increasing a lot. And that's really difficult to deal with because it's mixed and quite a lot of it is toxic. So that's a problem area. And I'm not going to even try to start talking about that. Now, plastic waste. So that's the one that started coming in the 60s and dominates people's thinking now when they think about rubbish quite a lot. So here are two contrasting views. We worry a lot about plastic because we get plastic bags in trees, or in this case, I was walking along past the Judge Institute, the Judge Business School, and there had been some plastic waste. So this white plastic, which had festooned all the trees in front of the judge. I don't suppose they were very amused at all, because it's jolly difficult to get down. I gather these are called witches' knickers. But a much more serious situation here in India, if your streets look like that, you really want to worry about it. You think something should be done. And then the marine environment, which we don't see in the same way until David Attenborough came along with his amazing Blue Planet series with these spectacular and horrifying views of how marine life was being affected by the plastic waste in the ocean, so entanglements and substituting for food, so things were starving to death. And our rather parochial view here of a nice beach on the west coast of Scotland with marine waste washing up on it, which isn't the same order of magnitude, but nevertheless concerns us. Most of the waste gets into the ocean from places where the waste is not so very well controlled, so Asia, and 40% coming from two rivers, the Ganges and the Yangtze. It gets in from municipal waste sites, it gets in just by rubbish being dumped, and it gets washed down to the ocean. So I'm going to continue to focus on plastics. And this diagram shows us how much waste comes from different sources. And packaging is the biggest amount. So 38% of plastics consumption comes from packaging. The next biggest sector is building. But we worry about packaging a lot more because it's so transient. And so packaging we may use for a matter of days, weeks, not much more than that. And so its cycle time is fast. It goes round that production, use, disposal loop really fast. There's a lot of it. If you put plastic into buildings, then you hope that it will stay there for a good length of time. So we hope 50 years or more. So there's a lot of it, but it's not so problematic. So what's food packaging for? It does quite a lot of things. It lets us handle liquids and powders. It provides mechanical protection for all those delicate things. And so really does prevent a lot of food waste. It acts as a barrier layer. So smelly cheese, nice smoked salmon, and bags of salad. Protective atmosphere for the salad, vacuum for the smoked salmon, and a barrier layer to keep the smelly cheese under control. And so a function of packaging really does improve product shelf life, so preventing damage, but also this really important function of being a barrier layer. Now, everything other than a barrier layer you can manage with other materials. They'll still have a high carbon footprint, but they're not necessarily plastics in the same way. And so they avoid the attention of the plastic police who want the anti-plastic movement. The barrier layer function is really best done by plastic, and it's quite a problem when that's under threat, and we have to find substitute materials for that. So the problem is at the end of life that the packaging doesn't go to the places that it ought to, and so it ends up in the rivers, the judge business, school trees, and on our beaches. So what should happen to it? So on the right-hand side, we've got basically good things at the top and bad things at the bottom. And the three top sort of good or good-ish things are some sort of recycling, where the plastic is retained in some sort of a loop or reused for something, or at any rate, not going to anything too inappropriate. There's the other bit where it's used for sort of low-grade purposes, which may or may not be recycling. And I'll talk a bit about energy recovery later on. Landfill is what you think it is. It just sits there harmlessly, but it takes up space, and it's not being used in any helpful way. So it's a waste of material. This is what we traditionally think of as recycling. So you take your waste plastic, you sort it, very carefully actually, clean it, shred it, put it into this machine here called an eremer, and it gets squeezed and heated, squeezed out at the end, sort of toothpaste-like, and gets turned into pellets, which can then be used for making new stuff. So that's recycling. And it saves materials. So polymer recycling, don't need to manufacture as much new polymer because we've got this recycled polymer which will replace it. And so it saves about a ton of CO2 per ton of polymer. That's what the party line is, and it's more or less true. But let's delve into that a little bit more and do a bit of nerdy analysis of what recycling means. So this is real recycling. We take milk bottles and fizzy drink bottles and we recycle them into the same articles. Not necessarily 100% of recycled material these made from, but there's something of a closed loop here. So currently with the milk bottles, we can use about 30% recycled material. We need to add virgin material to get the properties. These are actually pretty demanding. They're very, very thin, those bottles. And the fizzy drinks bottles, you can use 100% recycled material, PET, but most of them do have a mix. But that one can be 100%, and there are commercial examples out there. So that's like for like, but a more broad definition, I think, could be that we use the material for an application which is as demanding. So we're really using the material properties in the same way that this high-grade material was designed for. So that's recycling. Now, this is another recycling. This is office flooring, so carpet tiles. And there are quite a lot of operations out here that are doing this. It can be closed loop, so it's sometimes operated as a product service system, a take-back scheme, or eco-leasing. And so you don't own the carpets, you own the fact that your office is carpeted. You buy it as a service. And there are people who come in, you say the carpet is needing replacing, or they have people coming in and monitoring it. They say, okay, it needs replacing. They come in and they change it, they take away the old stuff. Because it's their carpet, they can recycle it, reuse it, and make new carpet out of it. So they've got the technology set up for doing a closed loop there. This is recycling, and that's a good process, and it's actually saving a lot of raw material. Upcycling. So this is a bit of a niche market here, and it's when you can use waste material, but you're not necessarily getting better mechanical properties out of it, but you're getting a lot more money out of it. So here's a lampshade made out of 10 old bottles, and it's selling for £195. That's definitely upcycling. You don't get that much for the bottles themselves. There's quite a clever process here for making 3D printer filament out of your own bottles that you make at home. So old PET bottles at home turned into filament that you can then make stuff out of. And there are quite a lot of operations like this. So that's a sort of upcycling. There's nothing big scale here. There are no big commercial operations, but there are an awful lot of very small scale operations, and a lot of the community action around recycling. That's a sort of upcycling, and each operation doesn't do very much. It may do quite a lot for the local community, and added together, they make quite a big difference. And they make people feel better, because they're doing something about their waste plastic. All right, here's another operation. So this is in the Himalayas. And if you look at this picture up here, that's the recycling station which has got the best views in the whole world. So up in the Himalayas, very isolated community, stuff goes up there and it doesn't go down again because it costs to take it down. And so waste plastic just forms new sort of baby Himalayas up in the Himalayas. And you can see that picture up on the left is a small mountain of waste plastic. So this was an operation that was set up in collaboration with actually the Institute for Manufacturing, but the government as well, to do something about that waste and to find a good use for it. And so what they're doing is they're taking the waste and they're turning it into floor tiles, which are used in the village. It's local people that do it. They're benefiting from it, and they don't need to buy the floor tiles because they're their own waste. So it's providing employment. It's using the stuff that's there, the historic rubbish, as well as the new stuff that's being generated. And it means that their rubbish mountains are gradually declining. So this is a well thought out operation, and it's something which they're trying to replicate in other isolated areas, so a real community project. And the sorts of equipment that they use are stuff that is robust, that you can buy sort of off the shelf, and so trouser presses, very cheap, and that's what used for making the tiles. So nothing fancy there at all. I got involved with it, just helping them to do the mechanical property measurements. So that's the good bits. What about the downcycling? So you mix rubbish. Mix it with plastics and use it for making street furniture. Bit more sophisticated, perhaps. Mix it with concrete. Mix it in concrete. So it degrades the mechanical properties a bit. It does provide a little bit of fibre reinforcement, but it's lightweight and it provides thermal and acoustic insulation. And so this is something which people are looking into as a way of using some bits of plastic, but also getting some slightly different properties in their concrete. But it does degrade the properties. That's downcycling. So we've given some examples here of why we might recycle. So what are we trying to do? The first thing is to recognize that the waste can actually be a valuable raw material. It's not just rubbish, but you can use it for something. And so think of it as a raw input material for another process. So if we do it properly, we are reducing the demand for new material. And with everything that goes with that, finite resources, and whenever you make stuff, you have environmental impact from the energy you use, water that you use, and pollution, bad things that are generated. So all of that, if we can reduce the amount of new material, that should improve things. Reduces the quantity of waste, so stops stuff from getting to inappropriate places when it doesn't get into the places that it should do. So less landfill waste, and with any luck, less uncontrolled waste in the environment. If recycling is really easy, then more of the waste should go there. But the other thing is, it makes people feel that they're doing the right thing. Now, this isn't completely cynical, because it raises awareness of waste as being a potential resource, not just somebody else's problem, perhaps our problem. It would be really nice if the government took this a little bit more seriously. They make a bit more noise about it than they used to, but they don't actually do as much as they ought to help the recycling program. I'll talk a little bit about the ways that they do cause it to happen, but they really haven't put their mind, no, they haven't, I don't know, governments don't have minds, definitely not our government, but they're certainly not putting resources behind this in the way that they could. So how do we assess what the environmental impact is of recycling? Well, we have to measure something. And there are two standard ways of doing that, which are something like an analysis tool, a life cycle analysis, LCA, or an eco-indicator. And I'll talk a little bit about both of those. But there are lots of factors which also need to be considered. And I'm not going to talk about those at all. But there are geographical things. So if you're thinking about the environmental impact of recycling, a lot of it is to do with energy. If your energy is green, if you're making all your electricity from renewable resources, then the carbon footprint is much lower than if you're using fossil fuels as resource. So that's a really big one, which can make a huge difference to how you actually measure the impact. I was looking at recycling, upcycling, downcycling. So if we're looking at saving material, what sort of substitution level is important there? What should we quote? And what is being replaced by the recycling? If you're doing a life cycle analysis, then one of the key things that you've got to get right is to decide how big your system is. So, what's a system? If we're making some stuff, then you start off with raw material and you go through making the stuff and assembling it and using it and then throwing it away. And each of those has its own supply chain going in. I'm not drawing all of them because there are too many. Each of those has its own use cycle, and more and more and more. Where do we stop? How on earth do we assess this? So if you're trying to do an LCA, you have to artificially set some system boundaries. So here's the sort of system boundary that you might set. And it's got a little bit of this and a little bit of that, and it's avoided a bit of that. But you can see this deliberately vague green dotted line. If I shift that a tiny bit, I'll get a different answer. And that means that if I'm doing an LCA, I can be really quite sneaky about what answer I get just by moving the borders a little bit. So LCAs are great and they generate huge amounts of very official looking data, but you can get whatever answer you like if you're unscrupulous. Or even if you're scrupulous, but particularly if you're unscrupulous. So LCAs are good, but it's not actually quite as hard and fast as it looks. So thinking about polymer recycling, a common metric is CO2 emissions, global warming potential, and that's what we tend to see most of now. And so the sorts of things that you will see quoted are comparison between using recycled and virgin polymer. So if you use recycled polymer, then we've got these pale blue bars here. If you have to make the polymer from raw materials, then you get the dark bars. And so the recycling is clearly having a huge effect there on saving CO2 emissions. And if we look at the carbon footprint of recycling polymer waste and just seeing the breakdown there, most of the energy does go in the recycling process. And so that's energy. Remember the green energy bit there, it makes a huge difference where that work is done. The next biggest category is transport. And that's important, and we'll come back to that. We can do much more profound environmental assessments. So LCA, there are 14 common categories. They're being, new categories are invented for every operation. And so there are lots of different categories that we can use here. They're all different metrics. If we try to add them together to form a single metric, then we have to make arbitrary decisions about what value to place on them. So you can add up your apples and pears and prawns, perhaps. They're all very different. But if you do that, then you can get a chart, something like this one that we've got down here, which gives you some idea of the differences between different polymers. So some polymers are much more easily recyclable than others and with a much better environmental profile. It can be done for all of them, but sometimes it's more beneficial than others. So the average figures that we get for polymer are from mixes of these added together. So I'm going to have a slightly deeper dive into a bit of food packaging. So this was some work I did with a company called Sealed Air at St. Neots, which makes plastic packaging for cheese and other things. And it wanted to use its in-house waste for something, didn't want to throw it away. And so I came in with my wonderful PhD student, Di Morgan, and we tried to find a process for dealing with their in-house generated waste plastic. And that was his PhD. So this comparison chart here, we've got cheese packaging, of which I'll say a little bit more, and chicken packaging, which is not quite so complex, but is still reasonably complex, and the packaging itself. And so we've got the carbon footprint of the food itself, and we've got the carbon footprint of the packaging. So the eco indicator just looks at carbon footprint, doesn't look at anything else. And so this picture here, this eco indicator chart, is completely dominated by the production of the food. So cheese, this is cow cheese. And so it comes from long-lived cows, which do a lot of belching and other things, and generate a lot of methane. And so that dominates the chart here. The chickens are much shorter lived, and vegetarians don't like this picture because they would much prefer that the chickens had a bigger carbon footprint than the cheese, but that isn't the case. The packaging is a tiny little red line which you can just see. Most of the impact comes from the food. So remember the function of packaging, the packaging that was there to prevent food waste. That's something which is really worth having. In order to see the packaging at all, we have to magnify that disposal bit and think about what happens if we do recycle the packaging. The answer is we get a very tiny amount of energy back from recycling the packaging. So, the take home from this is, if carbon footprint is what you really care about, then you should use the best packaging here, and that turns out to be plastic packaging. There are maybe other reasons for focusing on recycling, but it's not here to do with carbon footprints. So, a little bit more about the cheese packaging. What's it for? Why is it so complex? Well, that's some cheese which is not dead. So it's maturing in the package. And when it matures, it releases carbon dioxide. And the carbon dioxide has to be able to get out, otherwise your package will explode. But you need to be able to stop oxygen from getting in. You need to stop the water from getting out. And you need to keep the smells in. And you've got a single layer of plastic that's got to do all of those things. And it does it not by magic demons, but by just having different barrier functions for the different molecules. But it does mean that it's pretty complex. And so here's a film. This is actually 9 layers of polymer. They're co-extruded in a single process. They come together, they form this plastic film, and they're all different polymers. The really important one is this oxygen barrier. Remember I said that barrier layers were important, and here's the oxygen barrier. That is the one that really, really matters. And that is EVOH, which is a ethylene vinyl copolymer. And that's the one that makes this material really difficult to recycle. Because when you heat it up, it releases HCl, hydrogen chloride, chlorine, and decomposes and is very unpleasant. So noxious fumes come off. When you recycle polymer, remember my erema there, we need to heat up the polymer until it gets to about toothpaste consistency and can be squeezed out at the end. So if there's a temperature difference between those two processes, that means it should be recyclable. And in this case, we found that there was indeed a processing window that we could use to recycle this polymer, and we could have made things like flooring from it. as so often happens, the person who was particularly interested in this moved on from the company and the rest of the company wasn't interested. So we did the work, we proved that it could be done, and then they never actually made use of it. But any polymer can be recycled if you put enough effort into it. This one could have been recycled, but not easily. And it would have been downcycling. So this multi-layer film is not easily recyclable, but there's huge pressure now for every sort of packaging to be either recyclable or biodegradable. So this multi-layer film, it needs to be recyclable if we're permitted to use it nowadays. So let's just analyze this. Could we use a single polymer to fulfill the functions that we need? So we're going to look at this all-important oxygen layer, and we're going to look at alternative plastics and see if they can do the job. And I'm going to look at the relative thickness that we need, and the carbon footprint, and the cost. So common polymers that we use for packaging, polythene of two different sorts, and PET, the fizzy drinks bottle material, the polythene, things like milk bottles. So the polythene has to be ridiculously thick to have enough barrier function. PET, 20 times thicker, but that's still a film as opposed to a box, which is what the other ones are. Carbon footprint is bigger for everything else, so all compared with EVOH at 1. The cost is actually lower for PET because EVOH is a really expensive polymer, but it's more for the other ones. And so in this case, for this function, PET is the best substitute, but we've still got a much bigger carbon footprint and it's thicker. But then we have to do it again for the next properties such as CO2 or water. If we do that, we still find actually that PET is the one polymer that could fulfill these functions, but we need much more of it. It would be recyclable because PET is fairly easily recyclable. So in theory, it's recyclable, but the carbon footprint is bigger for using something other than this really effective thin multi-layer film, which is not regarded as recyclable. So we've got a bit of a problem there. I said that none of the answers were easy. So, end of life is a problem. Why don't we recycle more polymers? There's a real technical problem here, as well as all of the logistics, gathering and sorting and cleaning. Problem is that once you've made a polymer, you can't purify it. So things that go into the recycling process, that's what's going to come out as your final polymer. So it's got to be really well sorted, it's got to be really clean. And that costs, that's difficult. And analysing polymers is not at all easy, and identifying the small amounts of additives is really hard, and they can mess up a recycling process. So quality assurance is a big problem. Profit margins are small, oil prices are low. I won't say anything about what's happening in America, but that's not going to help. If you're going to make recycled polymer, you need to be able to sell it. And quality control is important, and so you only get good money for really good quality recycled polymer. But then there are people aspects as well, and there are skepticism about the recycling benefits. And that's actually quite important, and I think that that's one of the things that feeds through into the government. They know subconsciously that it's just rubbish, and so not to be bothered with. But the real barrier at present is economics. This is a costly operation. The UK doesn't have enough processing capacity, so most of it goes abroad. we're building new plants but not quickly enough. And so 60% of our waste goes abroad, nominally for recycling, but make your own judgments. The Netherlands, it does go for recycling. We buy it back from them. It goes to Turkey, and we won't ask too much what happens there. So what would help? If we collected more of the plastic waste, then operations would actually improve. And a key difficulty there is, do you know what to put in your bins? I don't. Wales turned out to have the third best recycling rate in the world in 2019. And in Wales, I mean, first, they're Welsh, they're not English. They're much better behaved than us. They had a unified collection over the whole country, and people knew what to put in each bin, and it worked. So perhaps with a well-managed operation, you might be able to get better results with people putting the right stuff in the right bins. But you need to build up the markets for recycled material and increase the capacity. So then there are statements about what we're trying to achieve. This is driven by industry. It's not actually driven by government. This is used to advise the government here. And so these are targets which have been set and will be missed. There are people aspects which are really difficult, so I'm not going to talk at all about those. They're much too hard. And then there are bits of legislation which come in, which are not always quite well thought through. So this particular one, 30% recycled content in all plastic packaging. So PET bottles, you need 30% recycled PET. Trouble is, that was all over Northern Europe, and there just wasn't enough recycled PET to go around, and there still isn't. And so it's cheaper for people to pay the fine for disobeying the law rather than to buy recycled PET. So the recycled PET prices have gone above the virgin prices. That's not good thinking. Now, flexible packaging. I was talking about the cheese packaging and how we need to make it recycling. The trouble is that the cheese is wrapped in flexible packaging, and we don't deal with that very well at all. So the post-consumer collection of things like bags is problematic. There's lots of variety. Some of it really mixed, like our multi-layer food packaging. Some of it just different sorts of plastic bags. It tends to be contaminated, and it's really difficult to handle, not just at the collection stage from your bins where it flies around the road, but also when it gets into the recycling plants, when it goes and entangles all the machinery. So it's genuinely technically difficult to recycle this. And it's not generally collected in the UK. The local councils, it's still only about 20% that collect flexible plastics, but they're all supposed to be doing it by 2027, and that's not going to happen either. So most of it is collected by supermarkets, the big supermarkets with their front of store collection. And so here's the government putting in responsibilities here. So simpler recycling. And so industry is involved in this because it's being funded by the extended producer responsibility legislation. And so sort of industry is having to pay for this. So it's in their interests to make sure that the legislation that's putting in place is something that is workable for them. So they're really involved in this. And there are targets that have been set here, which will be missed, but they'll happen not so long after that. So what can we do? There are really technical problems here, and so mixed plastics are difficult. We need to be able to separate them. We need to avoid colored plastic because that's an impurity. And so you've seen probably, being a nerd, I look at packaging a lot. So there's much less colored packaging about, and that makes it easy to recycle with high quality material. Improved sorting so that we can get higher value material. compatibilize and deal with impurities, so technical ways of doing that. Chemical recycling, where we're going back to breaking down the material to the monomer units, and some clever things going on with polymer dissolution, where you can dissolve up the polymer and actually do some purifying there. But other ways of dealing with plastic packaging. So other scenarios here. If you've got food packaging, then why not have the packaging degrade in the same way as food? So have compostable packaging. Packaging environmental. Is that the best solution? Well, there's a lot of muddled thinking around this. So people think that biodegradable packaging is green, doesn't use fossil fuels, and it does engender a false sense of security. It's okay, it doesn't matter. But in fact, it's still plastic packaging. And if it's composted, then we lose the embodied energy from the polymer. Most bio-based polymers come from fossil fuels. If they are bio-based, if they come from agriculture, then it's not your back garden stuff. It's industrial scale agriculture using lots of water, lots of agrochemicals. You can't distinguish them, and they can really mess up conventional recycling streams. And we don't make enough of them. So it's about 2% at the moment. And it's increasing, but we need completely different sources of raw materials here to be able to get up to appreciable volumes which can do anything like what we want. So that's sort of some of the reasons why we might recycle. Why might we not recycle? Well, go back to our picture here. The best things to do are avoid and reduce and reuse. Recycle is the third best category here. It's not the best thing to do with our waste materials. So delay the point of getting to recycling as long as possible. And certainly don't use anything which is single use, because the substitute materials, even if they're not plastic, they're environmentally very damaging. So we need to be focusing on not going around that use loop so fast. So designed for reuse and long lifetimes. So more durable. Knock-on effects from that, we use more material to make them more durable. We still want to be able to recycle them when they do get to the end of life. Plastic packaging from food, particularly emotive, and the knee-jerk reactions, the anti-plastic movement. Remember the function of the packaging in preventing food waste. But don't use more packaging than you have to, and don't use plastic unless you have to. But don't eliminate the packaging. Composting is it's a robust solution, so if it does get out of the environment, it doesn't do too much damage. What about this energy from waste? So energy recovery, we reclaim that. It can save fossil fuels at the moment for running our electricity generation plants. So thermal recycling. It's done in London. So London has quite a big energy recovery plant downriver, riverside at Belvedere, and this generates a lot of power. And the good thing is that the rubbish goes from central London down to this by barge with a really low carbon footprint. But in Denmark, they're rather proud of their energy from waste plant, and if you go into Denmark via Copenhagen, you see this, because they've turned it into a feature. It's got a ski run down from the top. It's about 90 meters tall, this, which in Denmark is a mountain. And so this is their only ski slope. And there's a climbing wall as well. So their energy from waste plant is something that they think is a good thing. Right, brief run on textiles. Most textiles are actually polymer, but they're regarded in a very different way. So textiles dominated by fast fashion, which is a comparatively recent movement, but it's caused a real explosion in the amount of textile use and hence textile waste. Culturally, very complex, and I won't try to go there. It's a disposable commodity, as seen by many people, and the operations are out of sight to us, so the manufacture, the disposal, they don't impinge on us in the same way that the plastic, consumer plastic waste does. And yet the materials are sometimes the same and the processes can be the same. But this is dealt with in a very different way. It's mainly manual, and the operations are mainly small scale and not automated. So a very different sort of territory. But it's a big problem, and it's 8 to 10% of global greenhouse gas emissions and a lot of water pollution. And Northern Europe, the demographics here are very different from the global ones, where most of the clothing is made out of polyester. And the really shocking thing that 40% of clothing manufactured is never worn. So what happens at end of life? Atacama Desert just gets dumped. Ghana, UK, most of our textile waste goes to Ghana. There's a huge market there in Accra. Anything that's saleable is sold at the market onto international sources, and the stuff that isn't used is just dumped and gets into the ocean on the beach here. Most of the waste is burned eventually. But there are recycling processes, and this is a fibre-to-fibre one, where you cut the textile break it up into fibres, and you can reuse those. Not very much, 1%-ish. Chemical purification. Some of these processes are the same as some of the ones which we're using for plastic waste. And there's a lot of development going on there. What could happen in the future? More artificial fibre. So PET and nylon are both used a lot in clothing, particularly PET, and it is recyclable without degradation. But it contributes to microplastic waste, so we need to be aware of that. There are people thinking quite sensibly about circular design, and so making sure that things stay in the loop for as long as possible. And circular business models, and so things like George taking back clothes and reselling. But it's pretty small scale at the moment. And the real thing is, can we influence consumer behavior? So understand how to break this fast fashion loop. Okay, quick canter around metals, where the situation is very different. So metals, they're relatively easy to recycle. Metal is high-value material. You can melt it, you can refine it, you can get really good quality materials. Impurities do build up, but you can get them out at cost. And there are processes there, new processes being developed, but this is an established model. This was a different approach. So aluminium, which is recycled, working with Julian Allwood here, we had just an idea that you can cold bond aluminium, and perhaps we could have a machine which sits in the supermarket car park where you feed your old Coke cans in, you turn a handle, and using that amount of energy, you can get usable material coming out here. So a tiny amount of energy. Recycling saves 90%, 95% of energy. This uses 5% of the energy of recycling, but you lose about 20% of the properties. And this was the process. No heating involved, and we could get good quality material out. It's not being used commercially, but it's an idea. Cement, this is another Julian Allwood thing. So cement is one of those things which is not recyclable because it's too chemically complex. But if you put it into an electric arc furnace when you're making your steel, then you can use it as a fuel there, and you can use it for making new cement. So it's a cunning process, difficult to see how co-locating the electric arc furnaces with the places where cement needs to be recovered from will happen very widely, but it's a process which people are really interested in, and if they can make it work, then that would be brilliant. So we got to the end. Recycling, it really is very material dependent. Generally environmentally beneficial. It does reduce resource consumption, and the quality, it can be crucial to economic viability, so it needs to be done right. We need to remember that recycling is well down in the waste hierarchy, so don't reach that stage if you can possibly manage to reuse or reduce. And recyclability shouldn't be an excuse for using single-use items, because those are always bad. Recycling isn't the only environmental parameter. Remember that cheese packaging, where we need to remember the function of the packaging in protecting the food. And anything else is usually less efficient and more expensive. Behavioral aspects, which I have not talked about because they're too difficult, but there are negative public perceptions, and that makes it problematic. So I said I'd answer a question. And the question is recycling just a load of rubbish? So no, but we could be doing it an awful lot better. And I hope that we will do as the future reaches us and the governments continue to do as little as they do now. So we hope for the future. Thank you.
Thank you, Claire. That was brilliant. Really interesting, exciting talk. I'm sure there are plenty of questions. We don't have too long. We've got 5-6 minutes for questions, so put your hands up quick. I'm going to ask one from online while the microscope's going around. How do we think...
Microscope? Microphone?
Oh, microphone, yeah. How do we think about trading off higher carbon footprint versus potential for multiple lifespans of use? Packaging material with a high carbon footprint that can be upcycled or reused, let's say.
Yeah. So I think that the reuse needs to dominate, really, and you need as many reuses as you can, and that requires people to buy into that as a model. You've used a lot more material, much thicker, but you reuse it for one of these rather than lots of plastics.
So horses for courses, basically.
Horses for courses, yeah.
This probably leads on from that. You mentioned various materials. What about glass? That's the one that people maybe think most about in reuse.
People think glass is wonderful. Glass is not a really good packaging material. It's very heavy, so you've got secondary transport requirements. It's quite dangerous. When you drop it, it breaks, and so that causes hazards there. Recycling glass takes a lot of energy, but it does save the raw materials. So recycling glass is worth doing, but glass as a packaging material is not the best. I can give you a much longer answer to that.
In the bar afterwards, perhaps.
In the bar afterwards.
A question over there?
Yeah. All right. BBC Radio have recently had very recently had a series of programs dealing with waste. And amongst many very disturbing facts that have been highlighted, one I want to concentrate on is the involvement of organized crime in the waste disposal and recycling. So no matter what progress we made technically and logistically and with management, are we in danger of all of that being undermined by good old crime?
You hear a lot about the crime aspects, with the thieves coming and stealing the copper conduction wires and stopping the trains from running and things like that. But it is a small amount of the total recycling operation, so it's not unimportant, but...
So I'm referring to, contractors who undertake to dispose of waste in a certain way and then cut corners by just putting it in landfill, which is on a very big scale, apparently.
Yes.
It certainly happens.
It certainly happens, yes. The problem, yes.
It's on.
As a practitioner of the waste industry, I can assure you that we're not all bad. One of the things that is probably holding this back is that people are measured on potentially the wrong things. So local authorities are measured on a percentage based on weight rather than potential CO2 impact. So consequently, everyone will always go for the heavy, the glass, the metal, the cardboard. And so your single-use LDPE films and stuff are very well down the packing order. You also no measurement on CO2 for that side of a country's metric. So therefore, there is no value put on carbon that is of any representative. And we still pay far less than we should do for the disposal of our waste. We should also stop using the word waste. It is just a resource. I get paid a lot of money for what I do, but that's because we pick our materials carefully. But as you said, if there were more value put on this, we would get more infrastructure. And with regards to the sort of criminal element, there is no value put on the policing of it. So people are able to carry on with impunity because we don't fund the policing of it.
Yeah. Everything he says is very true.
One,
I thought you were being an expert in the front. I could see you.
one last quick question from Howard. Quick.
What is it that's happening in Wales which gets this virtual process going? What are they doing?
Well, they seem to have an awful lot of bins, and they're clever enough to be able to put the right things into the right bins. But also they're Welsh, rather than English. So they seem to be better at it than us.
Okay.
But it does seem to be that they're interested in it. Yeah.
I'm afraid 9 o'clock is our guillotine, and the staff have to go home. So thank you very much indeed, Claire, for a fascinating talk. Big hand for Claire.